Okay, students, so I hope that you have been using Google Colab since last week for your programming. Am I correct?
Yes.
Yes.
Okay. Uh, have you also followed the instructions or the video that we have provided you regarding the installation of Anaconda? If you haven't installed it, I request you to please follow those steps and get the Anaconda installed. And maybe most of you might have installed it. So this Anaconda, just a moment. So up till now you were writing your programs in Google Colab, right? But for today, I'm going to demonstrate you how you can write the code inside something called as Jupyter Notebook. Now, why I'm asking you to follow this one also? I mean, no doubt, Google Colab is not bad. Okay, we, we can still use it, but this is a cloud-based editor, right? So all the programs that you are going to write, they will remain there in the cloud. Okay, and sometime maybe you want to develop your own projects, your own application, and maybe you want to put them in your systems, so that even if there is no internet connection, still you will have access to those applications, that code. So and being a data analyst or data scientist or machine learning engineer, Jupyter Notebook is one of the frequently used editor, right? So we have already explained you through that video how to install Anaconda. And when you install Anaconda, all the data analysis related packages, Jupyter Notebook and Python will get installed automatically. So there is no need to explicitly install these packages or softwares. So all you have to do is, now in my case I'm using Linux operating system. In your case you might be using Windows. So all you have to do is just open a command prompt like this. Okay, uh, to open command prompt in Windows, you will have to click on the start button and then type cmd or command prompt, and then there will be one black color icon will be there, and just click on it, and that will open a new window. Okay, where you can write your commands, just something like this. Okay, and by default here the path will be C users, something like that. Got it? Now you will be able to repeat the same steps only if you have installed Anaconda. Otherwise, I request you to write the same code in Google Colab. Fine. Now all you have to do is type Jupyter Jupyter Notebook and then hit enter. Okay, now it is a good practice to create a different folders uh, to keep the code related to that particular topic, right? So this way you will have a better organized code. So what I'm going to do here is that first I'm going to create a folder called NumPy. So I think this untitled here. Here is the new folder which I have created, and now I'm gonna rename it. So I will call it NumPy code. And then now let me open that one. Yeah, here we go, NumPy. So if you create different folders for each of the topic, and you can put your related code in that particular folder, right? Now here I'm going to create a new Python 3, which is nothing but a Jupyter Notebook file. and you can see that it is having a similar structure as that of your Google Colab. I hope this is not confusing you. I mean, as previously in the last week you people have used Google Colab. The step is not that much straightforward as was the case with the Google Colab, right? In Google Colab, you just have to visit that web page and you can create a new notebook and start writing code. Here you will have to open the command prompt, type the command Jupyter Notebook, and then such kind of UI will appear, right? Here you click on the new button to create a new file. Otherwise, rest of the things are similar. You can see that here you have the file name. So I will again name it NumPy. NumPy programming. Fine. So we are done with the creation of this thing. And now I'm going to start with NumPy. Now, first of all, try to understand what is NumPy, what is this NumPy, and why we should use it. So in the last week, you people have learned some different aspect of Python programming. Can you please let me know what are those topics that you have learned? So things like input output, right? Performing basic calculations. Apart from that, you might have also learned about the list data structure. Remember the list data structure?
Yes, sir.
So what is the advantage of using list data structure?
It can be edited, sir, anytime.
Sorry, can you please come again?
Sir, it can be edited. Like it can be, the data can be changed.
Yeah. First of all, we can store the sequential information in it, right? And we can update it as and when required. There are lots of operations that you might have also studied. One more important feature of list is that, suppose this is my list. In that list, I can have integer as well as float, as well as text value, right? So different types of values I can accommodate inside a single list. This is not the case with other programming languages where they have array-like structure, right? If you have declared array A in C language or Java or anything, if it is of integer type, then you can store only integer values, right? If it is float, then you can store only float values inside that array. So this is major advantage of this of using list in Python. But this feature comes at a cost, and the cost is that it requires a lot of memory space to store the list data. Memory consumption is high. So obviously, if something is taking a lot of memory, then it is obviously going to take longer time to process that particular data, right? Just a moment. So now when it comes to data analysis, data analytics, you will be having data that might be running into millions or even billions of rows, right? There might be 100 or even 1,000 number of columns. So when you have such a huge data, and if you represent such data through list, then obviously you can see that because of its high memory usage, it will take a lot of time to do some processing, to do some analysis on that data. To overcome this problem, a new library was designed and it is called as NumPy. Let's search about it and let's see what it says. I mean, as far as the Wikipedia is concerned. NumPy is a library for Python programming language, adding support for large multi-dimensional arrays and matrices. So first of all, it is a library for Python programming language, and it has a support for multi-dimensional arrays, along with large collection of high-level mathematical functions to operate on these arrays. So when we have a data, we do calculations, right? And real life data, I mean, if you consider the structured data in particular, right? Structured data, which is in the form of rows and columns, in the form of tabular form, right? So if you use a list like structure to represent this kind of data, so we have already, I have already discussed what is the drawback of list. So to overcome this problem, to do the fast to optimize the memory, to do the data manipulation or data analysis in a faster manner, this NumPy was developed. Okay, uh, it stands for numerical Python. And because now let me show you one more image, if I could versus list. Yeah, here is that image. So you can see that on the left hand side we have NumPy array, on the right hand side we have Python list. In Python list you can see that it can, the items in Python list contains some memory locations which in turn points to the data itself, right? Whereas this is not the case with the NumPy array. You can see that the data can be directly represented here. So hence the memory usage is less, and hence they are faster to process. So considering all these facts, now let's write a program to create NumPy. So if you have,
Neele sir, could you
yes
switch on
sir,
your video? Could you? Your video is off, I think.
sure. Sir. Is it visible now, sir? So now that you have learned about the introduction to NumPy, the theoretic theory behind NumPy, let's have hands-on NumPy. Since we have already installed, I mean, if you have installed the Anaconda, there is no need to explicitly install NumPy. Otherwise, what you can do is you can just type this command pip install NumPy, right? So if you execute this command, NumPy package will get installed into your system. Even in case of what I can say, even in case of Google Colab, this package is already there, so you don't need to install it. So if I execute this one, keyboard, if I execute this command, you can see that it will say that the requirement is already satisfied. Next step is to how we can create a NumPy array. We can use list or tuple to create a NumPy array. For example, let's say a equals to, okay, now NumPy is something which is not part of core Python, right? So maybe we have already used some functions such as list, print, input, right? So these functions are part of core Python. But when it comes to using NumPy or any other function or functionalities, you have to explicitly import the library of that package. Just this is equivalent to include stdio.h that you might have written in C language, right? So those header files contain the definition of some functions, right? So similarly here, I'm going to write import statement, import NumPy as NP. So import keyword allows us to import a library or a package. So the name of package is NumPy. And afterwards, instead of every time writing that whole word NumPy, I'm going to alias it as NP. Then now let me show you how you can create the, here I'm creating a NumPy array called a np dot array, and to this function I'm going to pass a list. Let's say 1 2 3 4 5. So you can see that I have created a NumPy array, and if I try to, I want to use the same code, but instead of a list, I'm going to use tuple. So same data is there, but it is in the form of tuple. Oh, sorry. So that is also possible to create NumPy array. Fine. Now that we have created NumPy array, let's see some functions related to it. First of all, I'm going to use this type function. So it is showing numpy.nd array. So this nd array stands for n-dimensional array, and there is a len function which will give you how many number of items are there in that particular array. Now some attributes that I would like to discuss here with reference to the NumPy array. This include, now as in this case, you can see that I have used all integer values, right? So if you want to check that what kind of data type is associated with the elements in NumPy array, all you have to type is name of the array followed by d type. So it is showing me int 64. So when it comes to NumPy, there are multiple data types as far as integer data is concerned. We have got int 8, int 16, int 32, and int 64. So by default, at the time of creation of this array, I didn't mention any data type. So on its own, it has chosen the int 64. It means that each of the value in this array will use 64 bytes to store that data, right? Now, if you are confident that your array content is not going to exceed the value of 100, right? So in that case, you can explicitly mention the data type, that is d type here equals to int 8. So if you are coming from the other programming languages background, so you might be aware of the fact that, maybe in Java there is something called as short, which is nothing but 8-byte integer, right? So the range is -127 to +128, right? So similar data range is there for the int 8 data type, which I have used in NumPy. Similarly, you have got this, you have got int 16. Obviously, it will take 16 bytes to store the data, and the range is -32,000 something to +32,000 something, right? So in this way, see, earlier when I declared that array A, the data type that was used was int 64, right? So obviously 64 bit of memory is going to consume by each member of that array. And now if you know that whatever array that I'm constructing, that is A, if it is going to have the values in this range, then it doesn't make any sense to use this 64 byte of memory. So in that case, you can explicitly mention the data type for your NumPy array. Okay, so in this way you can, sorry, there is a typo. It should be D type. Yeah. Now you can see that it is having a data type of int 8. uh, if I create another array, okay, I will explain you I will give the example of float array later. Let's discuss about some other uh, attributes of NumPy array. Let me call it shape. So it is giving me the value 5. Now you can see that this output is in the form of tuple, right? And as of now, there is only one value. This is a one-dimensional data, right? One-dimensional array. So it is showing you just the value 5, which represents this five elements. If there would have been two-dimensional array, which I will show you very soon. So in that case, you will have two values as an output of this A dot shape. I will give you the demonstration of the same in a while. Okay, yeah, then A dot ending. So here is the output. You can see that number of dimension. Since this is a 1D array, it is giving me the output as 1. Then A dot size. A dot size will give you the count of elements present in that particular array. Don't get confused with A dot size and A dot shape. Shape basically gives you the number of rows and columns present in that array, whereas A dot size will give you the total count of the elements present in that array. Now to explain you this in detail, let me create another array which will be a two-dimensional in nature. B equals to np dot array, and in this one I'm going to create a 2D array structure. Okay, so 1,2,4, okay, followed by this. So you can see here I have got a two-dimensional array structure. So this is my main array. Okay, this first pair of brackets, it is representing an array, and this array in turns contain two more arrays that will give you row column like structure. So there are two rows, right, and four columns. Now if I try to print the different attributes of this particular array, you will get somewhat different result. For example, if I type b dot size, right, b dot size, so it is returning me value 8. Then b dot shape, b dot shape will give you 2 by 4, as there are two rows and four columns. You can have three-dimensional or even higher dimensional array in NumPy. Next one is size shape ending. Yes, that is the number of dimension, right? B dot ending. Now, since this is a two-dimensional array, we are getting output of 2. I hope you have understood this attributes now. And these attributes will come quite handy when you will be doing some image processing or neural network related applications. One more important point to be highlighted here related to the NumPy, that it is the basis for many other advanced data analysis, data analytics related packages such as Pandas, which is used for the data manipulation. Then some data visualization based libraries such as Matplotlib and Seaborn, right? So that's why NumPy is having quite importance. It is quite useful and very important library to be learned by the data person. One more thing I would like to mention here is b dot item size. In this case, it is giving me 8. It means that 8 byte of memory is required for each of the item or each of the element that is present inside a NumPy array. Okay, so yeah, I think one more is left. It will be dot d type. That will give you the data type of this particular one. So 8 byte means 64 bits, right? So with this, we have completed the first section of NumPy. Now we will move to the next part in which we will be using the indexing.
Dr. Nile, there is one query in chat. Please
Yeah,
answer
yeah,
that
yeah,
also
sure.
before go to session. Yeah.
Okay. Difference between length and size. Okay, it's a good question. See, as far as the length function is concerned, you can pass any type of object to len function. It could be the list, tuple, or even numpy array, right? So that will return you how many the count of values in it, right? Whereas this size function, it can be used only for the numpy array. You cannot use this size function on a list or like that, right? So if you might have observed, I have used this size function uh, well, by the way, this is not a function, this is an attribute first of all. So I have to use the array name numpy array, not any other array, dot size. So that will give me the size. But when it comes to len, okay, so I had mentioned you have to call, this is a function, so you have to call that function and then pass the uh, array name, right, or list name. It could be either numpy array or list, anything, right? So this is the major difference between these two things. So due to some technical issues, after 5 or 10 minutes, I will switch to another laptop. So it may take a time of 2 minutes. Sorry, participants, there was a technical issue at my end. So I'm going to share my screen and we will continue with our examples. Now, since I'm joining from my another laptop, so instead of typing each and every code snippet one by one, I'm gonna show you the code which I had already written, and it is in the Google Colab, because this particular new system that I'm using, it doesn't have that Anaconda or Jupyter Notebook installed, right? So these code editors are just medium to write the code. Doesn't matter which one you are using. Just a moment. Here we go. So we have earlier seen how to import the library of NumPy. Followed by that, I have shown you some examples, how to create NumPy arrays and some attributes. Now let's discuss about how we can use indexing in order to access or change a specific uh, element or a whole array or a column from a NumPy array. So maybe in the last week you people have already studied list, right? List and tuples. So whatever indexing notations were used for the list, similar kind of notations are used in case of NumPy. So all we use a square bracket notation and integer to access a particular uh, array, right? So just a moment. We're good to go. So we are gonna so all we use is square bracket notation for the index. First we mention the name of the array, which is a in our case, followed by the pair of square brackets, and there you can mention index, let's say a of 0. So if I have array a like this, sorry, starting with value 1, 2, 60, 70, something like that. So the first element can be will have location of 0. This will have location of 1 and so on, 2 and 3 and so on. So if I want to access any of these values, right, so I have to use this index. So if I write a of 0, it will give me access to this value of 1. A of 2, if I write a of 2, I mean this is how it is read, a of 2, then it will give me the value of 60. Understood? So something which you people might have already studied in case of list. So I'm gonna go some quite fast. Let me know if you have any questions or doubts. So here is my NumPy array. Let me increase the font size a little bit. Yeah, now it's better. This is NumPy array, and now here I'm using a of 2 to access the value 9. This indexing also supports negative indexing. So -1 is the last element in the array will have index of -1, right? So negative index, I hope you people are aware of it. Please let me know in the chat window. Okay, good. Now let's see how we can do the indexing when it comes to a two-dimensional array. So here is my two-dimensional array. Uh, we have got two arrays here within this two-dimensional array, right? So here we go. Now in this case, if I try to print a of 0, you can see that in the output I'm getting the whole array itself. So this particular complete array is located at the 0th location, because within this array A there are only two elements, the first array which I have highlighted and the second one. So this one is treated as the first element itself. Hence if I type a of 0 of or a of 1, I will get the whole array itself as output. But what if I want to access any particular value, let's say 3 or maybe 12? So in that case you will require two index two indices. Why? Because it's a two-dimensional notation, 2D array. So if you have got a 3D array, you will need three indices. If you have a four-dimensional array, you will need four indices to access any particular value from that array. So as far as NumPy is concerned, there are two different notations. We can write name of the array, square brackets, followed by row number, comma, column number. So let's say I want to access the value 3, this one. Okay, now it is located in the 0th element, right? This whole array was at the 0th index, and within that array the location of 3 is at the 1 is at 0th location, 2 is at 1 location, and 3 is at the second location. So that's why I have written 0 comma 2. So the moment I type 0 comma 2, I mean a of 0 comma 2, it will give me the value of 3. Similarly, same thing can be achieved by using a different notation, which is like this: a of 0 2. So here I'm using two different brackets notation instead of one bracket notation, where the indices were separated by comma, right? So both are valid notation when it comes to accessing uh, two-dimensional value from a two-dimensional array. Then next is index slicing. Again, same thing you people might have used in list, right? So typically when it comes to index slicing, the syntax name of the array, starting index,
You're on mute, sir. Can't hear you.
oh, is it better now? Can you hear me now?
Yeah.
Okay. So you will mention the name of the array, which is X in this case, followed by the starting index, which is 0 here, colon, then ending index. This ending index is not included in while printing the values, right? So the last index before this ending index will be considered. So from 0th location till the 3rd location, all the values get printed here. Not printed, actually we are having the access to these values. Got it? So you can see that the first 4 values are getting printed. The one at the 4th index is excluded here, right? Similarly, you can write, you can take any piece of your array and accordingly you can get access to it by using this index slicing option. One more thing is there, which is called as index slicing. Index slicing step size. So by default, the step size is 1, even though I have not mentioned here, this step size is 1, because every time the next value is selected from the 3rd location is at the next particular index, right? So if I write the same code, X 3 to 7, but let's say step size is 2. Okay, let me execute that particular cell where this X is declared. So you can see that it is printing the value at the 4th location, which is 34. Okay, and then the next value, and since I have mentioned the step size is 2, so it will jump 2 location, so 2 7, and it will print the 7. Again it will jump 2 location, but you can see that after 4 there is no value, so the output comes out to be 37 34 and 7 only. Okay, what do we have here? Here we have a 2-dimensional data. Okay, now X is a 2D array, and now you can see that here these first 2 values, that is 0 4, this slicing will be applied on the rows, and whatever is the remaining part of slicing after comma, it will be applied on the columns. Understood? So from 0th row till 3rd row, from 0th column till 3rd column, that is the portion of array that we have sliced here. So when it comes to 2D array, you will have to use such kind of notation for so here I have mentioned some different examples. You can just have a look at it later when you share with this one. Yeah, if
Dr.
you have,
Neelik, Dr. Neelik, can we share first quiz now?
yes, sir. Sure.
Do you have the link? No, maybe in the chat box.
Yeah. Sure, sir. Just give me a moment. Okay, participants, I'm gonna share the link. Uh, Copy link. Please check the chat box. I hope you have completed that quiz. Now we have just seen that how we can create np.array, how we can use this index to access any particular value, right? Now I'm going to show you how we can, by using index, how we can update the value within a numpy array. When it comes to one dimensional numpy array, the process is quite straightforward. I mean, same thing you might have done in case of list, right? So let me quickly show you one example, and then I will show you how we can update it inside a 2D array. So this is your one dimensional array, and let's say I want to update any of the value. In that case, I will write b of 0 is equals to 100, and then if I try to print b, you can see that value at that particular location have been modified. Going ahead, if you have array structure like this X, whose size is quite large, right? You can see the I mean, let's call this function some attributes: x dot size, x dot shape. So it's a 5 by 7 matrix. So if I want to change any particular value in this array, so I will have to use two indexes, right? So let's say I want to change the first value. So this first value is at the location 0 0, right? Because it is located in the 0th row, right? This whole array is represented by the 0th index. Within this particular array, this value 1 is located at the first location, which is 0 again. So I can write where it goes, x of 0 comma 0 equals to 100. And you can see that that value have been modified. Now I'm going to show you one interesting fact here. What if I just use a single index here, and then I'm writing 100? So you will find that at x of 0 we have this whole array itself, and the moment I write x of 0 equals to 100, all of these values in the first row will be updated with 100. Got it? Here I'm trying to initialize the last column with the value of 1000. Let me check. Let me rerun this code. No, that is not the case here. All rows from 6th column to the last column. Yeah. Now see, in this particular case, what I have done is just this. I hope you remember this first part is responsible for the selection of rows. Here I have not specified any value for the rows, which means that select all the rows, right? Starting from 0th rows till the last one, comma, select the 6th row, which is nothing but this column, sorry, which is nothing but the last column, colon, and nothing is mentioned. So it will go till the last column. And there I'm putting that replace all those values with 1000. So that is why I'm getting this kind of output here. So in such a way, you can, if you want to update any content of any particular row or a column to a single value, that can be achieved with the help of such coding. Okay, no need of this. Fine. Now here I have declared a 3-dimensional array. As you can see, this is the first array. Within that first array, we have got two arrays. This is the first array and this is the second array. Within that array, I have again two different arrays. If you want, sometime, you can write this code in a single line, but splitting them in different lines improves the readability, right? One more way to identify how many number of dimensions are there in your numpy array is just count the number of opening square bracket till the occurrence of the first value. In this case, you can see that there are three opening brackets, right? So it's a three-dimensional array. So I have written some code. You can see that some attributes I'm printing there, that is number of dimension is 3. If you want to access the first value in this particular from this 3D uh, numpy array, you can use this which is 1, right? So for this I will need 3 index, right? So I'm writing b of 0 0 0, so that is giving me the value 1, which is at the first location in this. So just go through this code. This is very simple and easy code to understand, since you already know the list and all. And I have also discussed about the slicing and all. Sorry, index slicing and all with respect to uh, NumPy. Here again, I'm trying to modify a value at particular location using this particular code. Now we will move to the next session, and after that we will have the another test. Here we will try to initialize the different types of arrays. So maybe when it comes to image processing or data manipulation, uh, there might be a need to initialize your array with some specific values, right? So it comes with lots of function. This NumPy comes with lots of function and allows you to achieve a lot of things. Let me give you some of these examples. For example, you want to create a NumPy array that contains only values of only zeros, right? So in that case, this zeros function will come handy. I have written x equals to np dot zeros, and to this function I am passing a tuple value. In this case, it is just a one value. So uh, it is going to create numpy numpy array containing 10 elements. All of them will be initialized with 0. Now in the next cell I have written the same code, but here now I have two values inside that tuple, so 4 and 5. So it will create array of all containing zeros, 4 rows and 5 columns. Here I am creating a three-dimensional arrays. All values are equal to 0 because of this zeros function. Similarly, if you want to create NumPy array containing only one values, we have got a function called once, np.once. So proceeding on similar lines, I have tried to create some NumPy array here, right? So by default, you can see that these functions are creating values which are of float types. If you want to explicitly change their data type to integer or something like that, then in that case, you will have to mention the second parameter here to this function, be it zeros or ones function. You can pass it d type equals to whatever data type you want to assign. Well, this was okay if you want to create, if you want to initialize your all array elements equals to ones or zeros. But what if you want to initialize array with a particular value other than 0 and 1? So obviously it is not possible to have the function for all of those, right? But there is a function called full, np.full. So here is the code: z equals to np.full. The first parameter will be the tuple, which is nothing but the shape of the array, how many number of rows and columns will be there, and followed by what value you want to put in that particular numpy array, so that you will have to mention as a second parameter. In that case, you can use this function called as np.full-like. First parameter will be the z. So it is not going to copy the values from the z. It is just going to copy the number of rows, how many number of rows and columns there in z, and it is going to populate that new array with the value of 44 in this case. So all the constant values that I have mentioned here, you can mention any value, any negative value, float value, anything. Next is, suppose if you want to initialize an array, NumPy array, with some random values. In that case, we can use this function np.random.rand, and there I'm passing the dimension, that is 4 cross 4. So it will create NumPy array with some random value selected. Then there is another function called randn. So it basically, I mean, you will have to mention the range here. Let's say 20 comma 40. Okay, so if I execute this code, okay, I have to print this x. Oh, sorry, this is no, sorry, this is not the code I wanted to show. It is rand int, sorry. It's rand int. Okay, rand int. So you can see that every time I will execute this piece of code, it is going to give me, it is going to select some random integer between 20 to 40. Got it? But this is going to give me only one particular value. But what if I want to create an array which will have the values equal to values within some specific range? Well, in that case, I'm going to modify this particular code a little bit. X equals to np random.randint. Range is given first 1 to 100, and then I have mentioned the size, which is the size of the array. Finally, the data type. So in that case, you can see that 3 by 4 array is constructed, and all values are falling within the range 1 to 100. Maybe during your junior college mathematics, you have studied about metrics, right? So there are lots of functions related to metrics also. So one of the concept you might have learned about something called as identity matrix. So you can also create identity matrix or array that contains all the diagonal element equals to 0 and others are equals to 0. So this is np.identity is the function. And if you remember, identity matrix is a square matrix, which means that the number of rows and columns are equal. So no need to mention number of rows and columns, that is 2 values here, just one value is sufficient. So here we get the 5 by 5 matrix, and you can see that it's an identity matrix. All diagonal values are equals to 1, remaining are 0. Then a repeat function. So you can see that there are tons of functionalities using which you can basically initialize the NumPy array as per your requirement. Here I have a equals to np.array. I have created this array which is having the values 1 to 5. Let's say I want to create another array where I want to repeat these values for 3 number of times. So I will write np dot repeat array a comma 3. So you can see that the values now this new array a1 is containing the 1 for 3 times, 2 for 3 times, and so on. Now by default, I mean, if you check the documentation of this particular function, actually there is third parameter which is called as axis, and by default this axis value is 1. So one thing to remember here, because when it comes to data analysis using NumPy and pandas, this particular thing will come a lot of time, which is called as axis. Axis. So it can have either value equals to 0 or 1. When it is 1, it means that row. When it is 0, it means column. So by default here, that axis value is 1. Just a moment, it is taking time to, yeah. Axis 1 is out of bound. Okay, now this is a only 1D array, I guess. Just a moment. Okay, now here, yeah, 1 equals to row and 0 equals to column. I have written here. Yeah. Now same code is there, but here this time I'm adding this axis parameter and setting it equals to 0. So it will perform this repeat operation for columns. So it is going to, you can see that earlier each value was repeated here for 3 number of times, but now in this case it is going to repeat the whole array for 4 number of times, and you will get a 2D array like this. Just a moment. So here you can see that we have horizontal repetition of the value. Here we have vertical repetition of the array itself. Please ignore this example. Should be equals to... Okay, I hope you have also copy function in list. Can you please give me the confirmation? Yes, student. Have you studied the copy function under list? If not, I will cover it again. But if it is there, I mean, if you have already studied it, then I don't want to repeat it. Okay, Abhishek, fine, no problem. Let's say I have got array A, okay, having values 1 to 4. And let's say I want to create exact duplicate copy of this A. So what I can write, A equals to, B equals to A. And when I try to print the value of B, you can see that contents of A and B are same. Fine. Then I'm performing some operation on B. Let's say I want to change the first value of array B, which is 111 in this case. So you can see that I have successfully modified the content of B. Now, the moment I print the content of A, you can see that A is also modified, right? Earlier, the value of A was 1234, but now it is again 111234. How it is happening? Because, just a moment, this was my array. A equals to 1, 2, 3, 3, 4, right? The moment I write B equals to A, so a variable B is created and it points to basically same memory location. So if any modification I'm performing on B, same will reflect inside your array A. Got it? So if you don't want such type of arrangement, right, then there is something called as copy function. So instead of writing this particular statement, you can write b equals to a dot copy function. So what this will do, it will copy the contents of A. It will provide a new memory location to B where the contents of A will get copied. So thereby now A and B will point to different memory location, different data. So here, now that here, if I make any changes, it won't affect the contents of A. So that is what is illustrated through this example. A equals to a dot copy, and later on when I change the contents of B, you can see that the B has been modified, but A remains as it is. Okay, now I think we have covered enough topics, and maybe we can go for the next test. So let me just give me a moment. Let me quickly share with you the link of that one. Yes, it is. Dear students, I have shared the quiz link in the chat window. Please check it and answer the questions in the quiz. And we will start with the remaining part of the NumPy array shortly. Students, I will be back in 2 minutes. Meanwhile, you may attempt that quiz.